Hello everyone and welcome to today's class. I am Samuel and I teach you physics. If this is your first time of coming across the channel, do well to like, subscribe and share. And also if you are a returning subscriber, do well to comment and like. Thank you. Now today we're talking about additions of vectors. In our last class, we talked about scalars and vectors, and I differentiated between scalar quantities and vector quantities. And I made mention of how vectors are being represented. We represent vectors with an arrow. This is the magnitude and this is the direction. And I say that vector quantities are quantities that have both magnitude and direction. And in the difference, I talked about the main mention of addition of vectors and scalars. I said scalars are being added with simple arithmetic, but vectors, you don't just add them using simple arithmetic. You use vector method in adding the quantities. And today we're talking about how we add vectors. For example, now, let's say if you want to add let's say a man moved a distance of 30 kilometers per hour. Sorry, a man moved sorry. Let me say a man moved a distance of 30 kilometers. Remember that distance is a scalar quantity. And then he later moved on that distance of 10 kilometers. Now, if they say, what is the resultant speed there? So, what is the resultant distance? What is the net distance? What you need to do? You simply add them 10 plus 30, which will give you 40 kilometers. This is what you use simple arithmetic to add the what? The quantities, and you got what? 40 kilometers. Now, let's talk about, let's say, force. Let's say a force is acting on a ball in the same direction. Let's say we have force of 5 Newton. Remember that force is a vector quantity. 5 Newton, okay, this one is 4 Newton, and another force of 5 Newton. And it says, what is the net force, or what is the resultant force? What do you do? Because they are acting in the same direction. Remember, vectors have both magnitude and what? Direction. Now, in that of the distance, what that about 40 kilometers, we not check the direction. But in this case, they are talking about what? Direction. Since these forces are in the same direction, what do? You use simple arithmetic. The resultant force will give you what? 4 plus 5. Why? Because they are in the same direction, which will give you 9 Newton. Now, suppose that these forces are in opposite direction. Suppose these forces are in opposite direction. Let's say this 5 Newton is acting here. What is the resultant force or the net force? The resultant force will be 5 minus what? 4. Why? Because they're in opposite direction. So the resultant force will be what? 1 Newton. Now let me illustrate this. For example, now, let's say a man, remember I'm talking about vector. Suppose a man moved 5 kilometers east. He moved 5 kilometers east and also moved 5 kilometers south. Alright? How do you get the resultant of this displacement? Remember, this is the displacement. Why? It has specified direction. Now, this is it moved 5 kilometers east. And then moved 5 kilometers what? South. How do you get the resultant? You get the resultant by using Pythagoras method. This is the resultant R. Since they are inclined at an angle 90, you use Pythagoras method to what? Get the resultant by saying R squared is equal to what? 5 squared plus what? 5 squared. And therefore r squared is equal to 25 plus what? 25. And r is equal to what? R squared is equal to 50. Therefore r is equal to square root of 50. So the square root of 50 is what? 7.07. You put the what? The unit kilometer. So when anytime vectors are at an angle, you use the vector methods. Not this not normal arithmetic. This is what? Vectorial method of what? Adding vectors. Now I've talked about resultant vector. What is a resultant vector? Resultant vector is that single vector which will have the same effect in magnitude and direction as the original vector acting together. Resultant vector is a single vector which will have the same effect in magnitude and direction as the original vector acting together. Like I said earlier, if two forces are acting on the ball, 4 Newton and 5 Newton, what is the resultant vector? They are in the same direction, so the resultant vector is what? 9 Newton, and I'm moving what in this direction. Now, what does it mean? They say resultant vector is that single vector. That means if you remove these two forces and apply only 9 Newton, it will still give you the same effect on this board. So the moment that those two vectors, which are the original vector, adding them together, this is what resultant. So that's why I say resultant vector is a single vector which will have the same effect in magnitude, the same magnitude, 9 Newton, in magnitude and direction. The ball will go in what? In the same direction as the original vectors 4 and 5 acting together. In addition of vectors, you have two methods of adding vectors. You have the parallelogram method and the triangle method. Parallelogram and the triangle method. Now, let's talk about the parallelogram. Now, in the parallelogram method, we have the law, parallelogram law, and parallelogram law states that vectors are represented in magnitude and direction by the adjacent sides of the parallelogram, that the diagonal line drawn from the point of intersection between the two vectors represents the resultant vector in magnitude and direction. What do I mean? If you have two vectors, let me say, if two vectors, let me say Q and P, they are vectors. And then, how do you get the resultant of this? Remember, there's an angle here. How do you get the resultant? You use parallelogram method, you represent them using what? By drawing a parallelogram. Then the diagonal line drawn from the point of intersection between these two is the what? Resultant. That's what the parallelogram law states. Parallelogram law states that if two vectors, let me say P and Q, are represented by adjacent sides of the parallelogram, that the diagonal line drawn from the point of intersection between the two vectors represents the resultant vector of these two vectors in magnitude and what? In direction. Now, parallelogram has a formula of, there's a way of getting this. The parallelogram method has a formula, and the formula is r squared is equal to q squared plus p squared plus 2pq cos theta. Now, this is related to cosine rule. But the difference between this and the cosine rule is that this one, there's a what? Plus. So this is the formula for getting resultant vector using the parallelogram. And remember I told you that vector quantities has both magnitude and direction. Now, after getting the resultant, you need to get the what? The direction. How do you get the direction? You use the cosine rule. Sorry, you use the sine rule. And in the sine rule, we say that A, we have sine A over A is equal to sine B over B is equal to sine C over C. You use this formula to get the direction or the angular direction of the vector. In my next class, I'll show us how we solve that using the parameter, getting the magnitude and the direction. If you want to get the magnitude, use the formula. If you want to get the direction, you use this sine rule. Now let me show you what do I mean by using this sine rule. You bring out this triangle from this now. Bring out this triangle and you have something like this. Yeah, you have something like this. Remember that this resultant R, this resultant, and this side is your Q, and this side is your what? Yeah, this is your P. This for the sides. Remember the side will be in your mathematics. The side will be in small letter. And the angles will be in capital letter. So here is your what? R for the angle. Here is your Q. Remember opposite sides. And here is your what? P. Now how do you present this using the sine rule? You say the angle sine R over the opposite sides over what? R is equal to sine, we choose this one, Q over the opposite Q is equal to P, the angle sine P over what? Small letter P. In my next class, you see how you use this to get your direction and how you use this to get your resultant vector. That's all the magnitude. Now let's talk about the triangle method. Now, for the triangle method, triangle method is a way of representing the vectors in form of a triangle. What does that mean? If you have two vectors, P and Q, you present them in form of a triangle. What does that mean? Let me say this is vector, this is your P, and you have another one, this is your Q. And then this resultant R. In this triangle method, you use the cosine rule. Now, for the cosine rule, you can say that R, that is the result R, is equal to Q squared plus P squared minus 2PQ cos theta. Now, the angle you're using here is the one inside. This one here. In my subsequent class, you will see how I will show you how you use the triangle method to get the magnitude of the vector. Now, if you also want to get the direction, you can use the sine rule. Like I said, you can still put these things here. I changed the alphabet, but it's still applicable here. You use the sine rule to get a what? Direction. Now, back to what I was saying, that vector quantities are quantities that have both magnitude and direction, and you want to add them, you don't only add them using simple arithmetic, unlike scalar that use only simple arithmetic. But in vector, if they are inclined at an angle, use the triangle method or the triangle method to do what? Get both the magnitude and what? Direction. Anytime you ask to get the resultant vector, make sure you try to do what? Get both the magnitude and the direction. Now in my next class, I'm going to show, we are going to have some problems, we're going to solve some problems on getting the resultant vector and the direction of the vectors using the triangle method and the parallel method. If you find this video helpful, do well to like, subscribe and share. And thank you.